One of the simplest ways to make thiols is by taking an alkyl halide and adding a thiolate ion. In an SN2 type reaction, the thiolate ion will attack the carbon with the leaving group and do an SN2 reaction to substitute in the thiol. Thiols can undergo a number of reactions. One of them is they can be alkylated. If we take a thiol and add a base like sodium hydroxide or sodium hydride, the base will remove the hydrogen on the thiol, make a thiolate ion, which will then attack an alkyl halide in an SN2 type reaction to give us a sulfide. Here's a look at the mechanism. Sodium hydride will remove this hydrogen, producing a thiolate ion, which will then do an SN2 reaction on a primary alkyl halide to produce the sulfide. This reaction works best when there isn't a lot of sterics around the alkyl halide, so methyl halides, primary alkyl halides, or even sometimes secondary alkyl halides work best. Here's an example with sodium benzene thiolate. It will attack the methyl group that is attached to this iodide to give us methylphenyl sulfide. Thiols can be oxidized with mild oxidizing agents such as hydrogen peroxide to produce disulfides. Disulfides can be converted back to sulfides by using reducing conditions such as a metal and an acid. For example, we can use zinc and HCl to perform this transformation. This is an important reaction, both the forward and backwards reaction in the chemistry of peptides. Disulfides are part of, or they make up, disulfide bridges, which are cross links between cysteine amino acids in proteins. Here is a simple look at the reaction. Here's a cysteine amino acid. Cysteines are recognized by the fact that they have a thiol side group. If we add an oxidant, two of these amino acids would link through a disulfide bond. If the amino acids are part of a peptide, then we can link two peptides through this reaction. Bridges are important in the tertiary structure of proteins, along with hydrogen bonds, ionic bonds, and hydrophobic interactions. Looking at this structure, we can see a disulfide bridge, an ionic bond between an ammonium group and a carboxylate group. We can see hydrophobic interactions between different alkyl groups on two different amino acids, and we can see hydrogen bonding between these two amino acids. These interactions help form the tertiary structure of a peptide, as you can see here by this structure. In addition, disulfide bonds are important in the process that we call a perm. In a perm, we generally take the disulfide bonds of keratin, which is the structural protein of hair, and we reduce the disulfide bonds with a reducing agent that will turn the disulfide bonds into thiols. That allows the hair to be molded in the shape that we need. And then after that process, if we add an oxidant like hydrogen peroxide, we can oxidize those thiol groups and back to disulfide bonds.